The James Webb Telescope has detected over 700 previously unknown galaxies. But what began as a much-celebrated coup soon turned out to be a perplexing mystery. Among the countless clusters of stars, there were some structures that stood in stark contrast to our established models and which as a result should not actually exist. These impossible galaxies show us that our cosmological worldview simply does not match reality. But what does this mean in a larger context? Do we have to finally shove our tried-and-true standard model? And if the universe did not ultimately originate in the Big Bang, how was it born? Stay tuned until the end and dive into the exciting world of these cosmic mysteries with us. On December 25, 2021, the moment had finally arrived. The James Webb Space Telescope plunged into the vast expanses of space and with it the hopes and dreams of experts on Earth. Specially designed for infrared astronomy, Webb has no small task ahead of it: to revolutionize our knowledge of the universe. And to achieve this ambitious goal, the most powerful space telescope ever built is literally looking back into the past. One of its main scientific tasks is to study the first luminous objects in galaxies that formed after the Big Bang and the so-called Dark Age 13.5 billion years ago. And Webb has already impressively demonstrated how it will take our knowledge of early cosmic development to a whole new level in 2023. After the first images had already overwhelmed the global public, Webb detected no fewer than 717 early galaxies as part of the JWST, Advanced Deep Extragalactic Survey, or JADES for short, that had previously been completely hidden from our curious gaze. In detail, the structures already existed 500 to 850 million years after the Big Bang, and researchers hope to use them to significantly refine existing models. But at the end of the day, the universe plays by its own rules and sometimes has surprises in store that turn everything we thought we knew about the early universe upside down. To understand what this means, we first need to remember what objects the experts had expected to find during this era. The cosmological consensus is that the first stars formed around 200 to 300 million years after the Big Bang and that the first galaxies were tiny dwarfs compared to their present-day counterparts. And that is only logical. According to our models, there simply wasn't enough normal matter at that time to form galaxies the size of the Milky Way. However, since the cosmos is apparently not particularly interested in our models, Webb has identified something in the depths of space that strictly speaking should not exist at all and which has been posing unsolvable problems for experts ever since. The impossible, the discovery of the impossible. Astrophysicist Ivo Lab and his team at Swinburne University of Technology in Melbourne had been analyzing some images taken by the NIRCam near-infrared camera from the James Webb Telescope's early release program. More specifically, the images showed a section of the sky near the Big Dipper, commonly known as part of the dawn of the universe. And sure enough, it didn't take long for L to realize that he and his colleagues had just discovered something extraordinary. He described his initial reaction to the groundbreaking find as follows. I ran the analysis software and it spat out two numbers. Distance 13.1 billion light-year. Mass 100 billion stars. I almost spat out my coffee. I knew we had just discovered the impossible. Impossibly early, impossibly massive galaxies. And the following explains why Pound was so keen on using the word impossible. To explain the existence of these early galactic heavyweights, the matter density in the young cosmos would have had to be 2 to 5 times greater than our models suggest, or the galaxies must have formed in a way that is completely unknown to us. Either way, the experts found themselves at an astronomical dead end. Both cases require a profound change in our understanding of cosmic evolution. So far, researchers have not been able to provide a clear explanation for this unexpected discovery. All we know for sure is that 500 to 700 million years after the Big Bang, there were already 6 galaxies containing 10 billion and in one case even 100 billion times the mass of the Sun. In other words, what should have been a small baby galaxy was already the size of today's Milky Way. Since Webb's discovery thus stood in stark contrast to virtually all current models of cosmology, the confusing structures became known as universe breakers. And as we now know, they ultimately marked only the beginning of a whole series of similarly puzzling finds. The galaxy JWST identified shortly afterwards existed just 290 million years after the birth of the universe and also appears far too large and starry for its age. In fact, it was only a few weeks ago that Webb added Sears 2112, a precocious twin of the Milky Way, to the star maps, which already had a fully formed central bar 11.1 billion years ago, and was also 10 times more massive than our home galaxy is today. The bottom line is that the early excesses of the cosmos are pushing our standard model of cosmology to its limits. And in fact, some researchers are even using these impossible structures as an opportunity to put forward an extremely controversial thesis. The universe cannot have come into being as is commonly thought. Or to put it another way, the Big Bang theory is wrong. But what is the background to this provocative assumption? The Big Bang. The problems with the Big Bang. In a nutshell, the term Big Bang refers to nothing more than the simultaneous emergence of matter, space, and time from an original singularity. But how can we reconstruct this literal beginning of everything today, or more precisely around 13.8 billion years later? Well, we owe this to the fact that the universe has been expanding since the beginning of time. However, the cosmos is not expanding into an already existing space. Rather, it's space itself that is constantly growing. And if we look at this development in reverse, we can calculate our way back to its beginning. We thus reach a point at which the density of matter and energy becomes infinite and all spatial distances become zero. The most outstanding evidence for the Big Bang theory is the detection of cosmic microwave background radiation. This nearly isotropic radiation was created around 380,000 years after the Big Bang and still fills the entire universe today. However, one thing should not go unmentioned. The corresponding theories and models do not explicitly deal with the actual Big Bang itself, but with the immediate period after it. More precisely, we're dealing here with a time frame of 1 Planck time and 400,000 years after the cosmic birth. However, what happened during the mysterious Planck time, which describes the smallest possible time interval for the laws of physics known to us, is completely uncertain. And although the Big Bang is firmly established among experts, it is not free from criticism. For example, the theory is unable to explain the how and why of it all. After all, what caused something to suddenly emerge from nothing 13.8 billion years ago? Can anything form from nothing? And was the process set in motion in some way, or was it pure coincidence? Cosmic inflation exciting alternatives to the Big Bang. Cosmic inflation is also still shrouded in mystery. In simple terms, this describes the phase in which the universe expanded by an almost ridiculously large factor within a fraction of a second. However, some researchers doubt that cosmic inflation even took place. But that doesn't apply to the Russian cosmologist Andrei Lin. Back in the 1980s, he suggested that the process is actually ongoing and only comes to a halt in some bubble-like subareas. And that has some remarkable consequences. In this scenario, each bubble would contain its own subuniverse. But that's not all. Since each cosmic world also has its own values for the constants of nature, it also has its own physical laws. In this case, our cosmos would not literally encompass everything, but would merely represent a tiny link in an infinite chain of universes. Alternatively, there is also a theory that our universe is not unique at all, but has already come into being and been destroyed countless times. In fact, some experts believe that the Big Bang was actually a big crunch. According to this model, the universe will literally collapse one day in the distant future. The initial assumption is based on the idea that in trillions of years, gravity will become stronger than the effect of dark energy. Once this point is reached, the expansion of the cosmos will reverse and accelerate into a contraction. At the end of this shrinking process, a single black mega hole will remain containing all matter, which will eventually swallow itself. However, it is conceivable that this very structure will serve as the seed of a new universe and that this cycle will repeat itself for all eternity. The physicist Nikodem Poplawski from the University of New Haven takes a very similar line. He locates our entire universe inside a black hole. According to this theory, a kind of primordial seed once matured at the heart of one of these mass monsters, which ultimately burst open and paved the way for the unfolding of the cosmic world. Consequently, black holes would also serve as natural gateways connecting two universes, with the restriction that the galactic door can only be passed through from one side. Admittedly, the ideas of a multiverse, a big bounce, and a black hole as a portal to other worlds are undoubtedly fascinating. However, just like the Big Bang, these models are unable to answer the questions of before and why. Stephen Hawking once said that time itself only began with the Big Bang, which is why it makes no sense to concern ourselves with before. But who knows, perhaps the collapse of this belief is only a new James Webb.